Hey, what's up? What's up? It is October 1st. So it is the 1st of October. It's the 1st of the month. Wake up, wake up, wake up. Hopefully, y'all woken up. And hopefully, you guys did some work on the CR. We'll talk about it today. Lock in. Yo, this is about the time of the trimester where people who, if you got like D's and F's, you're like, forget it, I'm going to give up. Don't give up. Keep going. You can do this. The goal is, I'm telling you what the goal is. Everyone to pass with a C or better. Everyone to pass with a C or better. That is the goal. And I need y'all to help me help you reach the goal. Because that's our goal. We gotta get there. We got to get there. I want you to have more than a C, but I'm like, at a minimum, I need you to get a C. Anything below that is not acceptable. That is not the goal. That's not what we're going for. So I need some of y'all to really lock in. For other of you guys, I'm like, don't get tired. I know there's a lot of tests, a lot of studying, a lot of this, a lot of that. There's a lot of stresses of school, but we've got one more month, and then the breaks begin. So October 31st, which is a Thursday, right? It's Halloween. Then you guys have off that Friday, so you guys have a 3-day weekend. Then the breaks begin because then on November 11th for Veterans Day we have a day off. Then we have Thanksgiving, and then we have Christmas and New Year's, and then we have Presidents, and that's in February. So we've got time off coming up. We just gotta lock in for this next month, y'all. Let's go. We can do it. We can do it. Okay. We do have a quiz on Friday. So there's a quiz on Fridays. It's going to be on CER. It should not be tough. It should not be tough. Again, it's going to be a quiz. It's going to be about the CER. All right, y'all. Let's keep it pushing. All right. So let's get on to this thing. So we're going to talk about this thing, and then you're going to write your rough draft today. So let's talk about it, okay? So I'm going to, let me see. Hopefully I have the thing to be able to pull up. I do. Right here. Okay, cool. So we are like ready to rock and roll. So I'm going to read this and highlight the things that I think are important. Even though two interacting objects exert equal, right? So exert equal and opposite forces on each other, right? On each other when they collide, the movement of each object, so movement of each object can be different if the objects have different masses. Use this use your scientific reasoning skills to explain why it occurs. All right. So I know for some of y'all, we're like developing the scientific reasoning skills, which is totally cool. So I would go with this. Okay. This is how I would do it. So the main like subject of the sentence is the two interacting objects. So if two interacting objects, and what is going on with the interacting objects? They are what? Colliding, or you could say collision, or this idea that when a collision happens, their equal forces are exerted on them. So if two interacting objects, right? Cool. And something else about these objects is they have different masses. So I'm going to go with different masses. Ooh, let's see if I can get some good writing in there. My hand is getting kind of far away from where I'm at. So let me scoot this pad on in. Can't wait to get my new one. So if two interacting objects with different masses have, I'm going to go, and remember this is the question, not the claim, have the same force exerted on them will, and so far we've got this part, we've got this collision, which is really this part about the same forces. So we got that part right here, the same force. Then we have the fact that they have different masses. Will their movement, right? Will their, and we got to use the right there, their movement be different. All right. Now, do you see how I included all of those different areas in there? Sometimes it's going to be hard to piece out like this, and then sometimes they're just going to ask you the question directly. So again, if two interacting objects with different masses, so we got this part and we got this part over here, have the same force exerted on them, that's what happens. Exert equal and opposite forces on each other. So the same forces exerted on them Then will their movement be different? Or I'm going to say, will their movement? I think that's what's got to be, movement. So each object has its own movement. So that is this last part. So what is your claim? Because remember, your claim must answer this question here. So do you think their movements, yes, their movements will be different when the same force is exerted on them, or will their movements be the same? What do you think there? Now what we're going to do is we're going to take a look, because you should be looking at your answers through the experiment. So you should be looking through pages 17 through 22. So what we do here is we're gonna move on to another space, and we're gonna look at some of these experiments. Are we still recording? Oh, we're still recording. Look at some of these experiments that you guys did and see what we observed. So this is what you need to do, is you got to go back in your memory, but then go back in your scientific notebook and see, like, yo, what did we actually observe, right? So cool, I'm gonna move this over there. I'm gonna move this right here. So let's just look at pages 17 through 22. And remember here, I'm gonna make this part big so that you guys can see this. Bam. So we should be looking right through pages 17 through 22. We've got the hand slap. That was that first one. That tingling feeling, right? Then the next one was Newton's body surfing. That's where we were throwing the ball back and forth, right, to the person. Okay, we got push me, pull you. That's the one with the what are they called? Spring scales, right? Then we got the recoiling slingshot. So we're gonna look at that one right now. Okay, cool. So I got this right here. Bam. Recoiling slingshot. So we have a mass right here, 500 grams, if you guys remember. Okay, so we're going to go like this. Okay, so it moves right there. Then we have a mass of 1,000 grams. So we're going to apply, again, the same force. Will their movement be the same or different? And as you can see, right, if you look like there, the one that was 1,000 moved very differently than the one that was 500 grams when the same amount of force was exerted on it. So again, what are we seeing? What is the actual science telling us, right? So let's look at some different things. So now we have we have a clay ball, and then we have the ping pong ball. Both of these have different masses. All right, we're gonna apply the same amount of gravitational force. So gravity is the same everywhere as far as how much force there is. The only difference is when you raise an object up, then gravity has more time to apply force. So both of these are going to collide with the same object with this counter, and we're going to see if their movements are different. And as you can see, their movements are different, and they have different masses. So what are you thinking? So these both of these can be pieces of evidence. And that one, that first one we looked at was recoiling slingshot, so that could be a piece of evidence. Hint, hint, evidence. And then also this next one we looked at was follow the bouncing ball, and that is there on page 21. Hint, hint, that seems like another piece of evidence. And then just for fun, I created a new experiment, and I just said, hey, this was not in our lab, but I thought, why don't we just try this? Why don't we use the slingshot to apply the same amount of force to the ping pong ball and to the clay ball and see if it has any difference in movement. So here's our ping pong ball and our slingshot. Whoa, okay. So you saw that. Okay, you saw that. Now we got the clay ball, and we're going to apply the same amount of force to the clay ball. Let's see if there's any difference in movement. Yeah, it seems like there's a difference in movement. So it seems like there's something about, right, when you're applying the same amount of force to two objects that have different masses, their reaction or their movement based on the exerted force seems to be different. Again, I just wanted to walk through some pieces of evidence so you can kind of think about how you should be thinking about this. So at this point, hopefully you've got at least two pieces of evidence. You got your claim, you got your question, and then go ahead and start writing your paragraph. Now, what I would do, this is just a hint, I would take that question and my claim and I would put them together, right? And instead of saying if, I would say when, right? So when two interacting objects with different masses have the same forces exerted on them, they will have what? Or they will have different movements, or they will have the same movements. right? And that's kind of how, whatever your claim was, if you said that they will have different movements, which I think that's what we're seeing here, okay, then I would say then their movements will be different, right? And then that could be your intro sentence to your actual reasoning paragraph. Remember, you need 3 pieces of evidence. Every 2 objects is one comparison. So that's 1 piece of evidence. We compared these objects and their movement when force was exerted. We compared these objects when their force was exerted on them and their movements. You got to find another pair in there from pages 17 to 22 of objects and their movements when force was exerted on them, and see if their movements were different. All right, y'all, that is everything for today. Get your rough draft done. Tomorrow we will type up the final draft. Peace.